Welcome. In this video, we will discuss scalar and vector quantities in under 10 minutes. In physics, a physical quantity is something that we can measure. Quantity here just means a number. For example, you can measure the weight of an object. You can measure the distance from your home to a local supermarket. And you can measure the temperature of a hot chocolate. The numbers we measure in these examples represent physical quantities. We physicists split physical quantities into two types, vectors and scalars. You may not know what these words mean yet, but by the end of the video, you will be confident in knowing exactly what they are. So what is a scalar quantity? You may want to pause the video here and independently have a go at thinking about what a scalar is. What do you think this means? When you think you have an idea, you can resume the video. Welcome back. A quantity that we only need to describe in terms of its magnitude is said to be a scalar. Keyword, magnitude. What does the word magnitude mean? Well, this just means the size or amount of something. It can mean the precise length of something. Great! Now we understand what a scalar quantity is. But what about vectors? A vector quantity is a quantity that we cannot explain using only a magnitude. There is something else we need to help us describe this type of physical quantity. That is direction. It is this need for direction that makes a quantity a vector. Therefore, a vector quantity is a quantity described by both magnitude and direction. We can represent the direction in many ways. For example, a direction can be given to you as a verbal or written description, but physicists like us write vectors as arrows. The size of the arrow gives the magnitude or number associated with the vector. And the direction of the vector is simply just the direction of the arrow. Here are 4 examples where the directions are given by north, east, south and west, and the magnitude given by the length of the arrows. Let us look at some examples, and then at the end of the video, you can try some for yourself. Okay, so our first example is energy. We measure energy in joules. We can tell that energy is a scalar because we don't associate a direction with energy. We can understand how much energy there is by just a number, the magnitude. So our second example is force. We measure force in newtons. When describing how much force acts upon an object, we also need to know the direction that this force is applied, to therefore know the result of this application of force. So because we need a direction and we need a magnitude, force is a vector. Okay, let's have a look at our next 2 examples. The first one is distance and the second one is displacement. Now these are different quantities. Distance only tells you the length of something. So for example, the distance you may walk to school every day. But displacement tells you the distance you walk to school and also the direction you take. For example, you walk 200 meters north to get to your school. So distance is a scalar because we only need the magnitude, and displacement is a vector because it tells us the magnitude and the direction of this distance. So take a look at our last 2 examples, speed and velocity. Speed tells us how fast something is going, and therefore we only need a magnitude to represent this. However, velocity tells us not only how fast something is going, but also the direction that thing is travelling. Therefore, velocity is a vector. It is very important to note here that distance and displacement are different, and speed and velocity are also different. Finally then, have a go at these examples. The first example is temperature. Pause the video now and have a think whether temperature is a vector or a scalar quantity. Welcome back. So temperature is a scalar quantity, and this is because we don't need a direction associated with temperature. We can have negative temperature, but the negative in front of the number for temperature does not mean a direction. Therefore, temperature is a scalar. Okay, let's look at the second example then. Density. Density is mass over volume. Pause the video here and have a think. Is density a vector or a scalar? Welcome back. So density is just a constant. It just gives us a number. We don't need to associate a direction with this, so density is just a scalar. How about mass? Pause the video now and have a think about whether you think mass is a vector or a scalar. So mass tells us how much of something there is. How much stuff does something have? The bigger something is, the more mass it may have, and the smaller something is, the less mass, the less stuff there is. So therefore, mass is a scalar, because we only need a number to quantify how much stuff there is. We do not need a direction for this. Our next example, weight. Pause the video and have a think. Is this a vector or a scalar? So weight is given by mass times by small g. This is a force. We measure weight in newtons. And if you remember from the examples earlier, force is a vector. Acceleration. Acceleration has a number or magnitude, and it also has a direction. Which way is something accelerating? That's something that we need to know to quantify acceleration. Therefore, acceleration is a vector. And finally then, let's think about momentum. Momentum is also a vector. We need to know which direction something is carrying its momentum.